how much more shall we be saved from God's wrath through him? For if, when we were God's enemies, we were reconciled to him through the death of his Son, how much more, having been reconciled, shall we be saved through his life? Not only is this so, but we also rejoice in God through our Lord Jesus Christ, through whom we have now received reconciliation. Okay, everybody, we are doing lesson 61B. Now, some of you were not in the room when we did lesson 61A. All right, that I think was Grandparents' Day. I can't remember, but we did lesson 61A, and lesson 61A will be posted with B and C online, so that if you did miss 61A, it's all going to be out there. Okay, so today we're talking about B, which is starting with the normal distribution. And this is just an introduction to the normal distribution today. Okay, so we're going to keep it real light. We're going to talk about standard deviations as we move along. We already know what a standard deviation is, right? We've already had the section on a standard deviation. Now this is our standard normal curve. And in the very center, notice the standard normal curve, the best I could graph it, there's a better graph in your book, is completely symmetric on the left and the right. Okay, the center of the standard normal curve is the mean, the mu, okay? Then one standard deviation to the right, two standard deviations to the right, three standard deviations to the right, -1, -2, -3 standard deviations to the left. Okay, so when we're looking at this, what they're trying to show you in the book right here is after they made the standard normal curve, they realized that this area in here, between -1 standard deviation and 1 standard deviation, has 68%, approximately 68% of all the data points. And they're showing you that on page 399. Okay, so you can take it to the bank that 68% of the data points are going to lie in between here, approximately. It's a really complicated formula that gives them that, but you can round it to 68% because that's close enough. All right, in your book, what percentile of the points lies between the -2nd and the 2nd standard deviation? Wes?
68.
Not between the -2 and the +2.
95.
95. 95% approximately of all the data points lies between these two right here. Okay, and then lastly, between the -3 and the +3, see this line never hits ground. Okay, it continues, let's say my bottom line is down here. It continues to approach. It never touches. So there are still points, there are still data points outside that 3 standard deviations on each side. But they get fewer and fewer and fewer. So 99% of all my data points will lie between -3 and 3 standard deviations of the curve. This is on every standard normal curve. This is what it means to be standard normal. Okay? So basically, if I asked you, based on that information, Cleveland, don't lose me here. You need to stand up in the back of the room? Okay. If I asked you how much data is going to be outside of 3 standard deviations of the mean, you would say about what?
1.
About 1%. If 99% has to be inside the 3 standard deviations, left and right, then 1%, only 1% of the data is left outside of that 3 and that 3, okay? Now, you all have some questions that, because this is symmetrical, and I've got 95 in here, but I've got 68 in between these first two, then 95 minus 68 leaves me with what? 27 that can be in these two, all right? Because I'm just taking the 95 minus the 68. So you can answer an awful lot of probability questions just knowing these 3 things, All right, so if I wanted to know about how much data is going to be between -2 and -1, and then between 1 and 2 standard deviations, you would say, well, altogether it's 27% of the data. Okay, well, since it's symmetric, wouldn't half of that have to go there and half of that have to go there? Okay, so what's half of 27? 13.5. So we're going to have 13.5%-ish there, right? And we're going to have 13.5% of our data over there. All right, so then we look a little further. We've got 99% of our data between here, but we got 95% of our data in there. So what's the difference between 99 and 95? 4%. Since it is symmetrical, we can say, oh, I got about 2% of my data there and about 2%. These are all approximations, but it's close. Okay? And then, since I can only have 1% of my data out here, it's going to be what? 0.5%? 0.5% that's going to be in each one of those areas. All right? So, we can make a lot of predictions based on these categories, these values. Yes, Marcus?
What do we use this for?
Okay, suppose you were at Dothan, okay, you got to go to Dothan, and you had a question. They're very likely to ask you questions based on the 68%, the 95%, and the 99%, because those are very common values that everybody knows, okay? Just a second, and I will get to you. If I said we're talking about a standard normal population, all right, and I said that the mean of the population was 35, okay, and then I said that the standard deviation of this population age, I'm talking about ages, was 5, and how many people could be expected to be in the region of 30 to 40 years of age, and I gave you the size of the population. Say this particular population is 10,000, okay? So basically, you know from this data layout that you're talking about 1 standard deviation to the left, because 5 less than 35 is 30, and you're talking about 1 standard deviation to the right, okay? And you're going to have, that spread is going to have what percentage of your data? 68%. So then what do? You take 68% of 10,000, and you know approximately how many people in that population are going to be between 30 and 40 years of age, okay? The key is, once they give you that little tag, it's a standard normal population, okay? And they won't ever say that. They'll usually say it is approximately standard normal, okay? So once they say that it is approximately a standard normal population, then you can apply those 3 numbers, okay, those 3 percentiles. And you can tell a lot about the population just by knowing its mean and its standard deviation. Okay? All right, now, this is also in your book. This is talking about negatively skewed. Now, when you look at that, it's leaning to the right, isn't it? When it's leaning to the right, it's negatively skewed. I know, it's weird, but just remember it's opposite of what you think. This one's leaning to the left. It's skewed to the right. It's positively skewed. Okay, so those are just 2 things. Now, another thing that's in there that I did not get to put on the board was when they were showing you this 68%, okay, they showed you 2 curves. They showed you one like this that had a mean, right, and it had a standard deviation, 1 standard deviation, -1 standard deviation, and it was really high and curved up like that, okay? And what were they trying to show you? Then they showed another curve over here that much flatter. Okay, but they showed you the mean, and they showed you the standard deviation, and they showed you the standard deviation over here. Okay, and then they showed you that this part in here was still the 68%. What does it mean when you have, see this had a smaller standard deviation, didn't it? And a smaller standard deviation, Duncan, means what? Bless you.
Have a higher mean.
No, a smaller standard deviation. Remember I told you standard deviation is a measure of dispersion. If the standard deviation is small, that means your points are clustered about the mean more closely. Okay, and that means you're going to have all your data points kind of clumped right around the mean. All right, and you're going to have a much higher standard normal curve. If your standard deviation is larger, that means your data is more spread out, and you're going to have a bigger area. It's all still 68%, but you're going to have a wider area under the curve that's going to still be 68% of your data, but it's more spread out, so you have a flatter curve. Okay, so the larger your standard deviation, the more spread apart your data, the flatter your curve. Okay, the smaller your standard deviation, the data is clumped about the mean more closely, the sharper up, the higher it goes. Okay, so those are just some points. Now, everybody look at C. 61C. And somebody real quickly check my data points with the points in the book, because I want to make sure I have the exact data points up there that are in the book so that our numbers will come out with the book numbers and we won't be confused. Okay? So, what you're going to do is you're going to go to your you're going to go to your stat. Just go to stat. Hit stat. No second. Straight to stat. If you don't have a calculator, go to my desk and get one. Just make sure you return them at the end.
Could you do it on a scientific?
Only if yours has. If yours will have a data listing. Do you have a stat button on your scientific?
Yes.
Some of them do. A lot of them do. Okay. So what you're going to do is you're going to go and you're going to hit edit. Okay. You're going to go to stat and you're going to hit edit and enter.
Yeah,
Do
just
I get L1, L2, and L3?
Yes, L1, L2, and L3. Okay. Now, this calculator that I picked up is a dirty calculator. It's got points already in it. I'm going to tell you how to clear out the old data. All right? So I've got points all the way over here in L3. No talking, please. Okay? If you go up to the top, the very top of the list, you click clear and enter, and it will clear out all of L3. Then I'm going to move my cursor over to L2, and I'm going to go up to the top of L2, and I'm going to clear out my data, hit clear, hit enter, and it clears out all the L2s that are in there, no matter how far down they go. Okay? And then I'm going to move over to L1. I'm going to move up to the very top. I'm going to hit clear, and clear, and enter, and then I clear out all my L1. Yes?
I have X's and Y's.
You have X's and Y's. Okay, it doesn't really matter. You're going to enter everything in X's today because what we're doing today is called one variable stats. Okay, we're doing a one variable analysis. Yes?
One says L1, L2, L3, and then under it says frequency 1, L2, L3, L4.
Okay, don't worry about that. Right now we're going to go, did you hit stat and edit?
Yes.
Okay, good. Then just follow me here. Now we're going to take all of our points are going to go in L1. We're not even messing with L2, but I wanted to clear everything out, so we just had it gone. All right, now this is the data we're going to enter. There's 32 points. Make sure when you're done entering, you have entered all 32 points. Okay, if you find out that you missed a point, you can add it at the bottom and it won't be a problem. All right, so everybody enter, and it's going to take me a minute because I am not a fast enterer.
You want to say you want
Wait,
mine?
all of those?
You have already entered it? Good. Susie has already entered it. Thank you, Susie. All right, so Susie has my 32 points already listed in, and that's a help. Okay, now we're going to talk about one variable statistics. Now remember when we're doing a box and whiskers, which is what this is all about. This is a box of whiskers of a lot more data. than we're used to doing. Okay, remember a box and whiskers looks something like this, right? Where we have a median somewhere in there, we have a quartile 1 and a quartile 2, we have a max, we have a min, and this in the middle is our median. Okay, so we have basically the median of your data is quartile 2. The median and quartile 2 are the same thing. Okay, so we're going to go, since she's entered my points and y'all are working on it, I'm going to go to stat. I'm going to just go back to my stat button, and I'm going to go to the right with my cursor to the calculate button. And I'm going to enter under one variable stats. Okay, so everybody that's behind me,
You push enter for one variable?
yes, one variable stats is also under the stat button. So stat, calc, and then one variable stats is where you're going. Okay, so now notice that most of them will give you a little question here. They're trying to verify that they're looking for the data in the right list. We've put our list in L1, okay? So since it defaults to L1, it's asking you, hey, list L1. And I'm going, yeah, that's where my data is. So I'm just going to enter it, okay? Don't worry about the frequency list. It's not important. Skip down here to calculate and hit enter, okay? And now look at what they give you, okay? Let me get rid of this stuff here.
I don't even know. You say Megan or register since I already did this?
Yes. Okay. They give you,
That's why I never use copy.
okay, they give you an X bar. An X bar is 79.5625. Do I have the correct X bar that y'all have? Is it matching the book's X bar? Yes, we're matching the book's data. Good. All right. Shh. Now, you're going to see that it gives you some other things that we're not going to worry about. Okay? It's going to give you 3 things that we're not worried about right now.
Where are
Okay.
you seeing X bar right now?
Okay,
no,
if you do
no.
one variable stats, right? Okay, so then it comes down to this one. This is your standard deviation. All right, and the standard deviation is 11.66. Now, if you were doing a bunch of data and you were trying to find the standard deviation, you could look right there. Now, in this problem, we don't use standard deviation. We're doing a box and whiskers. We don't really need it, but I wanted to show you where it is. That's your standard deviation. Okay, and then notice it says n equals 32. That's where you can check to make sure you have the right number of points. And in some statistics problems, you need to know the n, which is a lot of statistics problems. You need to know the n. That just tells you how many points of data you entered. Okay, then if you see the little arrow there, scroll down, and you get a whole bunch more. Okay, and under the scroll down, they give you min of x is 55. Okay, they give you quartile 1 is 70, median is 81.5, quartile 3 is 89, and max is 96. Okay, so now when we go back to our little box and whiskers plot, which I'll put right here, we're going to draw our box and whiskers plot, okay, and it's going to have a median at 81.5, all right, it's going to have a quartile 1, this little box in right here is the quartile 1 is 70, the quartile 3 is 89, the end of the box, the max is 96, and the min is 55. Okay, and that's how you make a box and whiskers plot. So now, remember what our quartiles are. Okay, when we take our median, what are we saying? What's a median anyway? If I take a median, what am I saying, Zach?
All the numbers added up and divided by how many numbers?
That's a mean. How do I take a median?
It's
all the numbers.
Yeah, all numbers
Set
in
all
a
this
row,
numerically in a row and then
Okay,
The middle
so
number.
since I'm going, does it make sense, guys, that half of the data lies to the left of the median
C.
and half of the data lies to the right of the median?
C.
Yes.
C.
Okay, now, how do I find a quartile? How do I find a quartile? What is a quartile anyway?
Oh, it's the median between the median and the.
It's the median of the first half of the data. Okay, so basically if I put that first half of the data that's to the left of the median and I put it in order and I go again, right? I'm having my quartile 1. And if I go to the right of my median and I go again, then I'm going to get it, right? So can you understand when I say 1/4 of your data lies in here
Yes.
and 1/4 of your data lies in here
Yes.
and half lies to the right and half lies to the left?
Yes.
Okay, all right. So now we're going to talk, yes,
How did you get 70 and 89?
70 and 89 from my calculator. It told me what my quartile 1 is, which is the median of the first half of the data.
Median.
Okay, the quartile 1 is the median. It's like, okay, a quarter of my point, guys, it's the first quarter. A quarter of my data lies here. A quarter of my data lies here. Okay, now real quick, before we ring the bell, because it's a short day, remember what an outlier is. Shh. Peter, slash. Remember what an outlier is. An outlier, okay, an outlier is a point that lies beyond a reasonable length here, okay? And we have a formula for the outlier, which is on page 403. Okay, they're going to talk about outliers. How do you determine if it's an outlier? Yes?
If it's far outside of the normal set.
Exactly. However, there's a formula for determining if it's an outlier or if it's not an outlier. And this is the formula. This distance between quartile 1 and quartile 3, this distance here is called your interquartile range. Okay? Interquartile range is Q3 minus Q1. Okay? So what is our interquartile range? 19, right? 89 minus 70, 19 points. Okay, we have 19 is our interquartile range. Now, when I am trying to figure out if I have an outlier or not, I take 1.5, I multiply it by the interquartile range. Okay, now 19, I'm going to think 20 for just a second because it's easier to multiply. But 1.5 of 20 is 30 points, isn't it? Okay, so I know my distance is less than that. We can find it exactly. 19 times 1.5 is 28.5. Now, this is the deal. If I have a point that is 28.5 steps to the right of my quartile 3, it's an outlier. And if I have a point that lies 28.5 to the left of my quartile 1, it is an outlier. Okay, so basically it's saying, all right, if it goes more than 1.5 times the distance of the interquartile range, it's gone too far. It's an outlier. And it is what? Skewing our data. Okay, those outliers skew our data. I showed you one that was positively skewed and one that was negatively skewed. So all your other data could be pretty much, reasonably normal in its distribution. If you had an outlier, it's going to mess everything up. Okay, so usually a lot of times we just throw out the outliers. If it's when we're talking about our central point of our data, okay, it's like, okay, yeah, we have an average age of our population, maybe, 70 years old. But then we have this one guy who lived to be 150 years old, okay? And if we put him in there, he would skew all of the data, okay? So basically, those outliers, in order to figure out what most everything else is doing, we drop off those outliers in our calculations so that we don't get false readings. Okay, so outliers lead to skewed data, false interpretations. So we don't want, when we're doing a statistical study, we're trying to figure out what's going on, and we're using our data to make predictions and things like that. We don't want an outlier, one single 150-year-old man out there skewing the data, which is approximately normal, around a certain mean. But you can see how if we added him in, it's going to move the mean up a little bit, and it's going to make all the other data a little bit skewed. All right, so when we have an outlier like that, we will usually, for a statistical study, drop it off and say, we want to see what our core of points are doing, not this single outlier that's way out there. Okay? Any questions on 61? Yes.
So is lesson 60 due tomorrow since we weren't here?
No, 60 is due today, right now. So you guys put 60 in the box because I don't think we're going to have time to do that one.